Okay, well, we're talking about the space news from about the last month. This is May 1st, and it's going to cover quite a bit on the moon and Mars because that's where most of the activity has been recently. Get right to Mars here. Of course, NASA has put up the Perseverance rover, and which in turn dropped off the Ingenuity helicopter, shown here in a mosaic photo put together from 62 actual shots. Rover itself isn't doing a whole lot except for one major experiment. It has successfully generated oxygen by removing CO2 from the Martian atmosphere. This atmosphere is mostly CO2. This is really the first in situ resource demo there's been, which is going to really be a key to settling certainly, other planets or other bodies, even like the moon. They ran it for about an hour. They produced 5 grams of oxygen, which is good for about 10 minutes of breathing. So they're showing that, there are going to be ways to survive in hostile environments like Mars. Now, the first month has been pretty much dedicated to the helicopter called Ingenuity, mostly waiting around, photographing it, relaying the data. It turns out that's actually a fairly large part of its bandwidth and computing power, just managing that data. So it hasn't done a whole lot else other than keeping an eye on the helicopter. So from the landing site, it moved around a bit. It identified that this particular area shown in the blue dots would be a good flight zone in the landing field specifically for the Mars helicopter right here. And then it moved off to a safe distance, and it's moved around a little bit in the last few days, but it's still basically watching the helicopter. And of course, we had the first successful launch of any kind of aircraft, powered flight under control on another planet or another foreign body. There was actually a software glitch that showed up right away, where the rotor starts spinning, and then they're supposed to shift over to a flight mode. And sometimes it doesn't quite complete on time, and there's a timeout that hits, and then the whole thing shuts down. And after spending a long time looking at it, they decided rather than any kind of software fix, they would just change the command sequence and accept about a 15% risk of there being a timeout. So then they ran the flight. The first one rose up 10 feet. That was the very first flight. This picture you're looking at is looking down at the shadow of itself, looking down from the helicopter. So that was really quite a historic first. The second flight went up higher, about 16 feet, and moved around a little bit. One side comment here, what sets the altitude? You might think it's something to do with the atmosphere, but actually it's due to limitations of the instrumentation. They have a laser rangefinder that they use as an altimeter, and they were worried that it might not work. So somewhere between 16 and 33 feet is probably going to be about as high as this particular helicopter will go. Now, flights 3 and 4 started to get a whole lot more interesting. This is a case where they take off from their area, they fly around and come back. Flight 3 went up 16 feet and flew about 330 feet totally, and it went at a top speed of about 4.5 miles per hour. Flight 4 had the same timeout problem, but when they ran it again, they had the longest flight yet, 117 seconds, and they flew 872 feet, and they went as fast as 8 miles per hour. Now, it takes a while for all the images and sound to get transmitted from the helicopter back to the rover, and then from the rover through the satellites on back to Earth. So we will probably get more images and even more sound from this later. And a side comment on the speed. The upper speed is not really limited by aerodynamics. It's actually limited by computing power on the helicopter, because as you recall from this slide from last time, the helicopter takes snapshots along its flight path as a way to correct its inertial navigation. And it takes time to do that processing. And that's about as fast as they're not sure exactly what that speed is, but they're not going to go so fast that they go faster than the images can be analyzed. So these were very successful flights. This has really turned out much better than almost anybody could hope for. They were allocated 1 month originally, and the assumption was they would just leave the helicopter behind, and Perseverance would go on with its main mission, which is related to science of finding previous life on Mars. So that was considered a technology demonstration, and it was successfully completed. There'd be one more flight, which would be a one-way trip to a new flight zone. But now they've been given an extension on life for a minimum of 30 days, 30 sols, which is a Martian day, which is 40 minutes longer than an Earth day. Now they're going to show that it could be useful as an aerial scout, and that could go on possibly until August. It remains to be seen. They won't fly as often because the Perseverance really does need to get going with all of its side tasks. And as I'd mentioned before, just relaying all that video and data from the helicopter was taking a significant portion of the network bandwidth and the computing power of Perseverance. And one back-end limitation is around mid-October, Mars and Earth are on the opposite sides of the sun, and there's no communications path. So they want to get a lot of the science done before then. And that's part of what's driving the urgency of getting going with the rest of the Perseverance rover experience. On to the moon. Both human and robotic landing plans have had significant things go on. Let's talk about the biggest one right here, and that's related to NASA's Artemis program for putting humans back on the moon permanently. There was a contract for the lunar lander, which is what would take astronauts down to the surface of the moon. The original plan had been with 3 vendors, and then they narrowed it. They were going to narrow it down to 2. That should have happened earlier this year, but did not. But then all of a sudden, surprisingly, to everybody's surprise, a single vendor was selected. And when you get down to it, this was really forced by the budget limits that Congress had imposed on the human landing system. It turned out only one vendor could actually meet that. Unfortunately, it's already been suspended. That just news about that just came out this morning. There have been protests filed, which we knew about, but the Government Accountability Office is now going to investigate it, and there's going to be all kinds of litigation going on, and until that's all resolved, payments will be suspended. NASA is not going to be allowed to even meet with the winner of this. So the 2024 landing date, for a day there was looking like, well, maybe it's going to be possible again. Now it's looking a lot less likely. So who are the 3 contenders? Well, there was a team led by Blue Origin, partnered with Lockheed Martin and Northrop Grumman. There's a team led by Dynetics, and there was a SpaceX. Now these are more or less to scale. You can see if you look closely, there's the astronauts are all about the same size at the bottom of these photographs here. So you can see there's quite a difference in the scale of the solutions here. SpaceX, of course, in this case, was providing a variant of their Starship. It's slightly different, no fins, for instance. You don't need them if you're landing on the moon. There's no atmosphere. So anyway, the contract initially was awarded to SpaceX, and as for a derivative of Starship. And it was at a bargain price, $2.89 billion, as a fixed price contract. They were going to get 2 missions. The first one is a test flight to land without any astronauts, and then the second flight would carry a crew to the moon's south pole. And of course, SpaceX would continue investing its own money. They had originally said the Starship development was going to be in the 5 billion something range. And so the 2.89 billion is, cheaper than their total cost. So SpaceX is continuing to invest its own money in this. So the way this would work, that NASA would get the astronauts to the moon, is in several stages. First, Starship would get up to lunar orbit. Now to get there and have enough fuel to make it back, down to the surface and back, they actually have to refuel in Earth orbit. I'll talk more about that later. Next, the astronauts would fly on the Space Launch System, which is the other main competitor for heavy duty liftoff. They will go to lunar orbit in the Orion capsule, which has been, along with SLS, has been the primary effort so far. The astronauts would then transfer to Starship. They go down and land, spend a week, come back up to the Orion, and then on back to Earth. At the gateway, which had been proposed, that had been out of the plans for a while. That was going to be something that came later. The gateway was a lunar orbiter, and the idea is it's a place for storage of supplies and meeting and so on. But anyway, that was already out of the picture for the very first flight. So finally, Orion would return to Earth and would splash down with parachutes. That's the plan. Now, there are some hurdles involved in getting Starship to the moon for this job. The first one, of course, is finishing Starship, the upper stage in particular. It would need its full array of 6 engines. The tests they've been doing so far are only with 3. And of course, they haven't reached orbit yet. So when they have more engines, they would be able to reach orbit or even beyond, just with Starship. And along with that, though, there is the booster that's needed. That's called the Super Heavy. We had the Heavy, but now we have the Super Heavy. And that has not been tested yet. So that has to be developed, but it's using the same engines, and it would be reusable as would be all of the other SpaceX rockets. Just for a size comparison, it would have about twice the power of the Saturn V that was used for Apollo. And as I mentioned, this will require refueling in Earth orbit. They use liquid oxygen and methane as their cryogenic fuels. This is kind of a big deal that really had not been allowed before. Of course, landing on the moon is its own challenge. They haven't quite gotten landing on Earth down just yet, but they're working on that. They've already had plenty of tests with spectacular results in more than one way, unfortunately. But it turns out, really, when you get down to it, the biggest single issue is really not technical, it's political. The competitors, of course, are outraged, because they lost. Nobody likes to lose. So both Blue Origin and Dynetics have already filed protests, and the project, unfortunately, has stopped pending review, as I mentioned. The reason they're fighting over this is that the implications are huge. This is really a big deal. It's kind of a radical departure for deep space activities for NASA. It says that NASA was really now buying into in-orbit refueling, reusability, which wasn't really a factor in previous deep space efforts, and really large-scale transport of people and cargo. The previous goals were to get a couple of people here and there. This really allows the possibility of a much larger scale presence on the moon, and probably a shorter time ultimately to getting to Mars, since we're using the same rockets. So it certainly would solidify the SpaceX position, and obviously does provide funding for Starship. So not only do you get the seal of approval from NASA, but you also get funding. So, and again, not just for the moon, but since the same vessel, essentially the same ship, would be used for Mars, they're kind of buying into the Mars program as well. It just it makes it a whole lot easier. But SpaceX gets something in return as well. NASA has spent a lot more time out in space, and they know a lot more about life support and also power, including nuclear power, which ultimately you're probably going to need for deep space and Mars missions. Longer term, the real implications are that it could hasten the end of the SLS lifter, the Orion capsule, and the Gateway orbiter. And you think about why. Well, Boeing is building one throwaway rocket a year for about $2 billion each for delivering a couple of astronauts, and they're 5 years late. You compare that to SpaceX, that they're already building rockets on a monthly basis, including Starship, where they're running monthly flight tests. So they're going to, eventually there would be the question, why not just launch the humans from Earth on Starship? And it's that inevitability that's kind of scaring everybody who's not SpaceX right now. But the politics, as I said, will be the trickiest part. There's a lot of vested interests. All these programs for SLS, Orion, and Gateway were really kind of viewed as jobs programs in a very large number of states, and of course the aerospace companies as well. And that's, that can't be ignored. That's a major factor in the way we fund our space program. It also affects foreign partnerships. Foreign partners have been building modules for the Gateway, and if that's not even needed, how happy are they going to be? And there's a little bit of an unknown with the new NASA administrator. He was a big supporter of SLS, and he had a lot of friends in the traditional aerospace business. So it's not really clear how all this will shake out. Okay, in other lunar news, the robotic landings. Of course, there are several robotic landings coming up. Various companies, including Intuitive Machines out of Houston and Astrobotic out of Pittsburgh. In the case of Astrobotic, they've also picked SpaceX, the Falcon Heavy, not the Super Heavy, just the Heavy as the rocket for them to get there to the moon in 2023. Now that is part of the Commercial Lunar Payload Services program that NASA has. It was about a $200 million contract. They'll be delivering a 950-pound rover from NASA to the moon's south pole, and that's pictured down below here. I'm not sure why they have ramps going off on both sides. You would think coming off once would be enough, but anyway, they're just probably showing the flexibility. It's kind of interesting that the Falcon Heavy will just pretty much go right into lunar orbit, and then the lander goes down from there. There's no pause for Earth orbits. Some other space updates. Blue Origin. There's actually questions came up about this in recent news, so I'd spend a little more time on them. They have several programs, one of which is a New Shepard booster and what they call the reusable spaceship, which is a passenger capsule that sits on top of that. they're making a lot of progress. And what in fact they're doing, they've announced that on May 5th, people are going to be able to sign up, actually to buy tickets, basically. The teaser, they haven't said how much they'll cost, but you might guess that they might be comparable to what Virgin Galactic would be charging, which is something like $250,000 for a similar ride. I should have said, by the way, that so the booster is reusable. The passenger capsule comes back down with parachutes, so that's how that system works. So what they'll do is they'll take 6 passengers in it at a time. They'll fly up 62 miles, which is kind of regarded as the edge of space. And that's from their launch site in West Texas. The passengers will experience weightlessness for about 3 minutes. Total ride time is about 10 minutes. And there's no pilot involved whatsoever, so it's all fully automated. Now, they really have quite a successful record here. Out of 15 test launches they've done, all of them worked. Some of them have carried payloads for NASA or others, small ones where they only needed a short time in space, but they wanted some of that time. There was a test on April 14th that included rehearsing getting people on and off of the passenger capsule, but they still have not sent an actual passenger yet. That may come fairly soon. Before they sell tickets, they're going to have to actually demo somebody traveling on there. Now, what about their other efforts? Well, the next thing up is the New Glenn rocket, and that would be to go to orbit. And unfortunately, that's not going to be available until probably late 2022 is what they're saying right now, which actually caused a problem, of course, for Jeff Bezos's other project, which is the Kuiper project for providing another internet constellation competing with Starlink. That means he has to buy launches on other rockets, in this case from the United Launch Alliance. And they announced purchasing, I forget, 9 or 10 of the initial rides. These pictures here show their launch site in West Texas, and this was the most recent test launch. Some other smaller news, Northrop Grumman, we've talked about them before. They have these, what they're calling mission extension vehicles, that their goal is to get up to the satellites that are way up in geosynchronous orbit. Typically, they last for a while, but they run out of propellant for maintaining their exact position in orbit. So they go up there and they move them around and keep them going. And they've done that before in MEV-1, and they've just done it again with their second one. They captured a 17-year-old satellite. They latched onto it while it was actually operating. They never shut it down, and they managed to do that successfully. That's the last in this series. Their future plans are to have robotic arms to do repairs or upgrades of satellites. And for these kind of missions where they want to add new propulsion capabilities to old satellites, their plan is to install them out as a pod and then just move on and do other things, including assembling things in space. This effort is funded by DARPA. Not all space funding, of course, is done by NASA. DARPA is a Defense Advanced Research Projects Agency who typically funded a lot of the really fundamental research that got us things like the internet and really kicked off autonomous driving. They've really had a major technology impact over the years. The space station has been quite busy. We've launched 3 astronauts from Russia and 4 from the United States. On the top of 9. Interestingly, we're not even allowed to purchase any more flights to the space station from Russia. However, it turns out, I hadn't realized this until recently, cross-training is not really complete between the Russian and the American parts of the space station. So not everybody knows how to do everything. There's certain things that only the Americans can do and certain things only the Russians can do. And just to be sure that there's always somebody from Russia and somebody from America on the same space station, they've come to the conclusion that they need to trade seats. So we're not going to pay Russia anymore, but one America did go up on their latest Soyuz mission to the space station, and then they'll get a seat, on one of ours coming up next year. In fact, right now there's a huge number of people on the space station that's shown in the picture right here because they've had some bad weather and they haven't been able to do the return of the most recent mission. A real brief talk on the Chinese missions. I'll be brief because, of course, we have a whole guest speaker to talk more about this. But the Mars rover landing by China, it was still on schedule for mid-May. They never announced an exact date for it. but they've been quite active. They've also launched the core module for their space station. Unfortunately, the rocket that got it up there is going to tumble uncontrolled, probably within the next week. Coming in uncontrolled means that it could hit, places where the people live. It's not necessarily just falling in the ocean like you hope. It's generally considered bad form, besides bad economics, to do that. So that's about the only embarrassing part of this mission. Otherwise, it was quite successful. And they'll have about 10 more launches to go for completion. That includes visits by astronauts, cargo, and so on. Their other major project is the International Lunar Research Station. Well, make no mistake, it is really, China is the top dog in that, but Russia is a major player. And now they've decided to formally invite other countries. So they're trying to get international participation as well. In other space news, everybody probably knows this, but Bill Nelson was confirmed as the next administrator for NASA by unanimous consent. So now we get to this part of the meeting where people get, how many launches have there been since the last meeting, which was April 3rd. So it's almost a month, not quite. And as we said before, it doesn't count suborbital launches. So for instance, this picture that we have up here of the Blue Origin launch, that one doesn't count because they weren't trying to go as far as in orbit or beyond. So everybody wants to take a quick guess. I'll give you a few seconds. Okay, so let's see. It looks like a few people said less than 5 flights. People guessed 7 or 8, 9, 10, and 11, more or less equal percentages on that. No, I'd say that was pretty close. So it turns out the answer is 10. And we've already talked about a lot of these. Of course, this SpaceX is back to putting up Starlink satellites. They had several batches of those. A side comment about that, once they get Starship going, instead of putting up 60 satellites at a time, they'll be able to do 400. So they have a lot of interest in getting Starship going as soon as possible. We'd already mentioned, of course, the astronauts being launched by Russia and the United States for the space station. There was a big US spy satellite that went up using one of the last of the Delta IV Heavy boosters. There's only 3 of those left. And let's see, we talked about the core module for the Chinese space station. So that pretty much covers the news. I'll just close with paraphrasing Elon Musk, that you don't want to be one of those species that just is stuck on a single planet. We want to be a multi-planet species, and that kind of sums up my attitude. We could probably take a few minutes for questions if we want, but then we need to move on to the main speaker.
Yeah, it sounds good. I've made it so people can unmute themselves. If you have a question, I suggest just raising your hand and we could call on you, or you can put it in the chat room. One thing I would like to say, Greg, it looks like Elon Musk was wrong about one thing. Some people probably argue more, but I remember him saying at one point that he thought it'd be easier to actually land a rocket on the moon than to convince NASA that he could. So it looks like he was able to convince them without actually doing it. So.
Yeah, it may be convincing the politicians. It may be the tougher one.
Yes.
I got a quick question.
Yep.
Greg, hi.
Hi.
The Starship is huge, and I think the answer is already yes. They have an elevator in that ship or some other type of transport?
They do. It's about a 15-story elevator that's included as part of that. Yeah.
Yeah. It seems kind of cumbersome getting up and down around that ship.
Yeah.
Considering the environment that they've settled in.
Yeah.
I know.
I mean, they would face the same thing on Mars too. So wherever they land, they're landing upright. So they're gonna, they do need an elevator, and I'm sure it's powered. I don't think they're gonna make it.
Oh, you've seen the movie Ad Astra, probably. Do you see any similarity between that ship that went to that blasted off from Mars to the
which movie?
What's that?
Which movie?
Ad Astra.
Oh yeah.
Yeah. Do you see a similarity that ship and the Starship?
Yeah, I'm kind of drawing a blank. I can't quite visualize what it was even. Sorry.
Hey, Greg, on your inevitable question on the.
I'm sorry, I believe I said, is there any similarity between that ship and the Starship?
Oh, yeah, I said I'm not really sure because I don't remember much about that rocket, actually. Sorry.
Yeah, hey, Greg, on your inevitable question on the lunar landing architecture, it seems a corollary to that question might be why not launch crew on the Crew Dragon, which is already human certified for launch from Earth to low Earth orbit.
Yeah,
instead of
yeah,
having,
that's all.
instead
That's
of,
exactly.
yeah, instead of having to try to human rate the Starship that soon for Earth to low Earth orbit launch.
Yeah, that's a good point. Okay, well, I think we probably need to move on to our featured speaker, Ben Hewson. He's been a lifelong promoter of space travel and space technology. I won't go through all the things he's been involved in, but it has included National Space Society. In his day job, he's worked for decades in IT, including for NASA and FAA contractors, and his original degree is in computer science. And he's going to talk about China and space, starting from actually Chinese folklore. In fact, I guess all their stuff is named after Chinese folklore. I'll turn it over to Ben.